Hello, welcome everyone to the video lecture on VLSI technology. The subject is VLSI design and testing, which is introduced for the 6th semester Electronics and Communication Engineering, and the subject code is 21EC63. So today in this video I'll be discussing the introduction to the VLSI technology, like what is VLSI, how the VLSI chips are manufactured, what are the different IC technologies. So let's start with what is VLSI. So VLSI stands for Very Large Scale Integration. That means it is a process of integrating a large number of transistors onto a single chip in order to fabricate or manufacture the smaller, faster and more efficient devices. So it can be also told as the design and manufacturing of a complex electronic systems such as microprocessors, memory chips, and digital signal processors. The examples of VLSI devices are microprocessor and memory chips. So now let's see a definition of a very large scale integration. So it is an electronic circuit which consists of the central processing unit, various types of memories like ROM and ROM, and other glue logic, that is the logic circuits which are built with the help of the basic gates. So all together, which is put onto the single chip, which will enable the IC designers to add all this electronic circuits onto a single chip, can be defined as a VLSI. So we can say very large scale integration is the process of creating an integrated circuit by combining millions or billions of MOS transistors onto single chip. So in this slide, it has the different IC technologies that are discussed. So circuit technology, it is mainly based on the integrated circuit technology. The integrated circuit technology can be any one of this which are mentioned, that is it can be a bipolar, complementary metal oxide semiconductor, bipolar and CMOS technology, SOI technology, which is silicon on insulator, SING and GaAs. So here this table shows what are the different parameters that are advantageous with respect to the BJT and the CMOS. So the first is the power dissipation. So when considered with the BJT, the power dissipation is moderate to high, and when comes it with CMOS, it is less. Speed is faster and fast. GM, the transconductance of BJT is around 4 milliseconds, and for CMOS it is 0.4 milliseconds, which can be the input to output ratio for the MOS transistor. And when comes to the switch implementation, the MOS transistors are considered as the good switches and the BJT is poor when it comes to the switch implementation. And technology improvement, with BJT it is slower and with CMOS it is faster. So why CMOS? Why complementary metal oxide semiconductor? So these are all the advantages which makes a VLSI circuit to be fabricated using the MOS transistors. The first is low power dissipation, high packing density, scale down more easily, fully restored logic levels, and equal rise and fall times. So since one of the in complementary metal oxide semiconductor, both the transistors are not on at a time, which will lead into the low power dissipation. The transistors can be scaled down easily. Scaling is reducing length and width of a transistor is defined as scaling. Due to the scaling of a transistors, there can be a possibility of high packaging density. The more number of transistors will be integrated onto a chip, fully restored logic levels, and equal rise and fall times. So next is what are the levels of integration? Basically, we say there are 4 levels of integration, that is small scale, medium scale, large scale and very large scale. There is also another 2 levels of integration which are called as ultra large scale integration and giant scale integration. So small scale integration, Less number of transistors will be integrated, that is 10 components onto a single chip. The example includes logic gates and flip-flops. Medium scale integration, 100 components. The examples can be decoders, adders, counters and multiplexers. Large scale integration, more than 20,000 transistors onto a single chip. The example includes the memories and microprocessor. Very large scale integration, around 1 million transistors, which includes the high density processors like 16-bit processors and 32-bit microprocessor. And ultra large scale integration, more than 10 millions onto a single chip, which can be for the special purpose processors. And chain scale integration is about 10 million transistors on a single chip. The example includes embedded system or system on chip. Thank you for watching this video. In the next video, I'll be discussing what are the key components that are used in the VLSI design. Thank you.